Hello everyone. Welcome to the solution of LeetCode problem 1544 named Make the String Great. In this problem, we are given a string S of lowercase and uppercase English letters. So here we have to make the string good. So the definition of the good string is a good string is a string which does not have two adjacent characters SO5 and SO5 plus 1 such that SO5 is a lowercase letters and SO5 plus 1 is a uppercase letters or vice versa. So here, to make the string good, you can choose two adjacent characters that make the string bad and remove them. You can keep doing this until the string become good. After that, we have to return the string after making it good. So the answer is guaranteed to be unique under any of the constraint. So we have to notice that the empty string is also very good. So now for this example 1, we can see that the string is L, E, capital E, small e, T, CODE. Now here we can see that these two characters, which is capital E and small e, violates the good string property because one of them is uppercase e and another of them is lowercase e. So we have to remove it from the string S. So if we remove it, then the resultant string will be L small e T CODE, which is LeetCode. So here the explanation is in the first step, either I could choose I equal to 1 or I equal to 2 and both will result to the LeetCode. I hope you understood the examples. Now the constraints are the string length can be in between 1 to 100 and each of the character is the uppercase English letters. I hope you understood the problem statements and as well as the examples. Now let's move on to the algorithm. Now to solve this problem, we have taken the first example. Here, the first example is LeetCode. So this kind of problem can be solved using the stack data structures. So now let's see how can you solve this problem by using the stack data structure. So here, if we consider a stack and we know the property of the stack is last in, first out, which is LIFO. That means the element which appears in the stack at last will be removed from the stack at first. So here the algorithm is pretty simple. We have to iterate each of the character of the string from left to right, and there is a condition. If our current character is the lowercase letter, that means we have to simply insert it into the stack. Suppose currently we are in these positions which indicate the value L. So small l is a lowercase letter, so we have to insert a small l here. Now our pointer is indicating the small e, so it is also a lowercase character, so we have to insert a small e here. Now the mystery is our pointer is now pointing to the capital E. So wait, this capital E is the uppercase English letters. So according to the definition of the good string, we have to remove its subsequent or its previous small case letter. So we have to check whether the last character is the small case version of this capital E or not. So how can we do it? We have to take the top element from the stack. So by taking the top element from the stack, we will consider these comparisons. So now the top element of our stack is small e, right? So we have to calculate one thing. Now our current pointer is pointing to the element capital E and our stack top element is small e. So we have to find the difference of them. So if we find the difference of them, it should be equal to 32. Because according to the ASCII character series, we know that the capital A value is 65, capital B value is 66, and so on. Similarly, the small a value is 97, and the small v value is 98. So, if we subtract, suppose small a and capital A, their value is equal to 32. So here, by this 32 value, we can check whether the first character E is the uppercase version of this small character E. So here, the algorithm is pretty simple. We have to check if we found the small uppercase character, then we have to take the top element of the stack, and if the difference of their corresponding value is 32, that means one of them is the uppercase letter and another of them is the lowercase letter of the same character. So in this case, we have to remove the top element of the stack. So here, for this capital E, we should remove the small e. Now, our pointer should point to the next element, which is small e, which is this. Now, we can see that a small e is a small case letter, so we have to insert here. Similarly, all of the element after this is a lowercase letter, so we have to insert it here also. So here, we can see that by using this algorithm, we have discarded two elements, which is capital E and small e. So the final result will be small l E E T C O D E, which is small l is this, and the rest of the character is this. So this is a good string. So now I hope you understood the algorithm. Again, let's wrap up the algorithm. In this problem, we have to run a loop from left to right. And the principal algorithm of this problem is using the stack. So if we found any of the uppercase letters, we have to check whether the difference of the top element of the stack and the uppercase letter is 32 or not. If it is, that means we have to remove the top element from the stack and the process should go on. After that, we have to print all of the elements that presented in the stack. Now, it does not necessary for this problem to implement this algorithm using the stack. We can simply use this algorithm by using the C++ string method. The string method similarly performed according to the stack. We can simply insert the element from the back and remove the element from the back accordingly. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named makeGood, which is a parameter of string s. Now, if string s is empty, that means we have to return an empty string. Otherwise, we have to take a string result to store the answer. Now we have to run a loop from left to right, and this C contains the corresponding or the current pointer character or the current string character. Now we have to check a condition. If our current stack or the current string is not empty, and if the subtraction value of the current character and the last element of the current stack or the current string is equal to 32, that means in this case, we have to remove the top element from the stack. So for this string, we can simply use this popback function. Otherwise, if it does not happen, in this case, we have to simply insert the current element into the corresponding result string or the corresponding stack. After that, we have to return the result. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we have to iterate each of the element from left to right in the given string. And the space complexity is also big O of n because we are using extra memory, which is string result, to solve this problem. And in the worst case, the size of the extra memory can be equal to the size of the string. So we can say that the space complexity is also big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.